Hello, good afternoon, my dear students. Welcome to one more amazing session from Sri Chaitanya Academy Infinity and NEET YouTube channel. How are you? Welcome to the session re-NEET and re-RISE series. Here we are going to discuss about the physical chemistry formula revision from Ionic Equilibrium, and we'll discuss eventually with electrochemistry. How are you all doing? So in this moment, you don't read right from the beginning. We are here to make you to revise the short informative formulas from our YouTube channel. So those who are online, please like the session and share with your friends. Subscribe to Sri Chaitanya Academy Infinity Lane NEET YouTube channel. Without delay, I just want to give you very important informative suggestions. So NEET is already completed on May 3rd. But because of unfortunate situation, the NEET examination has been cancelled and another NEET has been given to you. And that will be on June 21st. So take this as an opportunity to make the examination so awesome and better scoring as compared to the May 3rd event. So I would say this June 21st. So more improvised persons will be attempting the questions. So competition or badega. So you have to face the impact and please follow our sessions. We are going to give statistic review of the basic fundamental concepts from physical chemistry, organic chemistry, inorganic chemistry by using YouTube channel. So let us start without any delay. So आज हम चर्चा करने वाले Ionic Equilibrium. Before going for this, bachcho, those who are online, please like the session, and once you just press the like button, so that will be visible in front of me, so session ka josh aur badh jayega. Okay, cook with me. Oh, sir says something on NEET scam. No, NEET, it was cancelled, and here we are not discussing anything, what is the scam, how it is done. So here from the Sri Chaitanya Academy Infinity Lane NEET YouTube channel, we are going to discuss about the betterment of the NEET result for the students. So that is the ultimate goal for all the students. So let us not be asked how it happened, who did this, why it happened. This is not the platform to discuss. So that's your life and you are the supreme for your life. To get the betterment of your NEET examination, Sri Chaitanya Academy Infinity Lane NEET YouTube channel always welcomes you to the best. Okay, let us not discuss anything related to unwanted stuff which is not academically supporting us. Do you agree with us? Okay, come on, bacho. Here, Ionic Equilibrium. So the problem comes with equilibrium principles that we apply in the ionic solutions, in aqueous solutions. So you have a strong electrolyte, you have a weak electrolyte. So strong electrolyte completely ionizes, weak electrolyte, it ionizes feebly, weak ionization, incomplete ionization. For that, Ostwald dilution law is given. Let us say a weak electrolyte like CH3COOH is ionizing reversibly, gives rise CH3COO minus and H plus, right? And let us apply, this is a weak acid, equilibrium constant Ki is given as CH3COO minus and HO plus and CH3COOH. When you see at equilibrium, what is the scenario here? The scenario comes, so C moles per liter 0 and 0, C minus C alpha and C alpha is going to be. At equilibrium, it comes to be here, bacho, Ka is equal to C alpha dot C alpha upon C minus C alpha. So Ka you can write this as a C square alpha square upon C of 1 minus alpha. Do we require this derivation? Absolutely no, but the end of the derivation, whatever it is there, you have to use it, and that's why I am deriving this. Ka can be written as C alpha square by 1 minus alpha. That is what it is mentioned here. And alpha is the degree of ionization. For a weak electrolyte, alpha is very, very, very small. Taki A 1 minus alpha आप इग्नोर कर सकता हूं, करने के बाद आपको मिलेगा अल्फा इज इक्वल टू नियरली इज इक्वल टू सी अल्फा से स्क्वायर, सी इज द मोलर concentration, so C alpha is equal to root Ka by C and alpha inversely proportional to the concentration of the electrolyte. So when concentration almost tends to 0 and degree of ionization is going to be nearly 1, so from there you can calculate the pH of the weak acids as well as weak base, and even for the degree of ionization of the salt hydrolysis also link it to here. So if you have any doubts in the session, you can ask by using a chat box and take a pen and paper and listen the class and write all the noteworthy points. Are you with me now? Now let us talk about common ion effect. So ionization of weak electrolyte is diminished or suppressed by addition of a strong electrolyte in it which has a common ion in it. It is straight application of a Le Chatelier principle. You just say ammonium hydroxide, if it is ionized to gives rise ammonium plus and OH minus. If we add a little bit of ammonium chloride in that, ammonium chloride concentration is strongly increased, and according to Le Chatelier principle, the equilibrium is going to be reversed. So I mean to say, the concentration of the common ion you have to consider. That point can also be helpful in solving questions from solubility product. So bacho, hope you understand. Any doubt you can ask us. If you take CH3 COOH and it is ionized to gives rise CH3 COO minus and H plus. In the NEET examination questions ऐसे मिलेगा, common ion effect can be observed by dissolving the which of the salt. Just you can take A, B, C and D. You can take sodium hydroxide, you can take CH3 COO Na and NaCl and all the above. Can you tell me which could be the answer for this question? Common ion effect is observed when the ionization of acetic acid by dissolving which of the following salts? I want the answer from the chat box. Those students who are online, please come on. So I'm here to explain all the concept and applications, and the concepts and applications that I am presenting in this current session, you know, it is going to directly can impact your NEET examination. Similar model of the concepts. Every concept I am discussing here comes in the NEET examination. If I discuss some questions, that will be in the sessions that you can see here. And I, Rahul, and if you see the answer for this question, you can say CH3COO Na is a strong electrolyte, gives rise CH3COO minus and Na plus. So this acetate ion is going to have a common ion effect in this. So answer for this question is going to be B. Right? Bacho, clear? Now let us talk about ionic product of water. Ionic product of water is the Kw. It is a product of the concentration of H plus ions and OH minus ions, and this value is going to be perfectly constant, and its value is going to be 1.0 into 10 raised negative 14 mole square per liter square, right? Now in this scenario, it is only constant at 25 degrees centigrade. Okay, and if temperature increases, Kw value increases. So that is also very important. That is also very important, right? And pH scale based on this ionic product of constant, you can see here it is clearly mentioned here. Kw is H3O plus dot OH minus ion concentration. Here this value is going to be a constant. You can also say that Kw is equal to Ka dot Kb. Ka is acid dissociation constant, Kb is base dissociation constant. Hi Sanjay Tej, increase in font size increase karna hai. Definitely I'll write it in a little bigger. So I think it is visible to you guys. Okay. Shiv Kishore, Right? Hope you understand. Those who are online, please like the session. I'm requesting you. And let us say, and very important thing is Px is equal to negative logarithm to the base 10 of x concentration. So similarly, pKw is equal to negative log to the base 10 of Kw. And Kw is equal to Ka dot Kb. So pKw is equal to pKa minus pKb. Yeah, Hashita, and its values, you see, pKw is a 14 because pH is going to be 7 at a neutral, and Kw is equal to 10 power negative 14, so that Kw is going to be 14. And also with increase in temperature, the value of Kw increases. For example, you can say at 25 degrees centigrade, it is 10 raise negative 14. At 98 degrees centigrade, it is going to be 10 raise negative 12. Do you have to memorize these values? Of course, no. Only Kw value, you just memorize this as 1.0 into 10 raise negative 14 mole square per liter square at 25 degrees centigrade. Apart from this, no value you need to memorize it. Please believe me. Please believe me. So actually, students preparing for NEET examination, rushing towards by hearting the concepts, by hearting the formulas. Here I am not asking you to by heart everything, including values. Whatever the values that is required when you solve a particular numerical, it will be given in the question itself. So you don't have to worry about this. Bacho, okay, come on, let's talk about so pH scale. It is given by Sorensen. It is a negative logarithm to the base 10 of Hu plus ion concentration. And you know the pH scale, it ranges between 0 to 14, and 7 is going to be neutral, less than 7 is going to be acidic, and greater than 7 is going to be basic, and it is going to be neutral. You know, this is the neutral, and this is called pH scale, and it is only valid 25 degrees centigrade. If the temperature, if you say pH is equal to 7, neutral condition, temperature is 25 degrees centigrade. Okay, if the temperature is increased, this pH scale, this scale has no validity. Okay, any doubt? So Hu plus is equal to 10 power minus pH, pH is equal to negative logarithm to the base 10 of Hu plus, and you can say here pH of aqueous solution is equal to negative logarithm. I said pH is equal to logarithm to the base 10 of 1 by Hu plus. So this is correct, this is correct, this is correct. Which of the following is true as far as the pH is concerned? You will be asking a questions based theoretical questions in the physical chemistry. Dear students, you might have seen in the previous examination May 3rd and the previous year's questions also. In the total 45 questions, you will be having hardly 5 numericals. Hardly 5 numericals in the total chemistry. So rest of the things, concept oriented, theoretical oriented, application oriented questions will be there. You need not have to worry to solve the lengthy calculations. How many of you fear about lengthy calculation? No worries. Here I am here to tell you how to handle the pH calculations. You can pH values and the nature of solution. If Hu plus ion greater than 10 power minus 7, the value of pH is going to be less than 7. And if Hu plus ion is equal to 10 power minus 7, it is going to be pH 7 and the solution is going to be neutral. And if Hu plus ion concentration is less than 10 power minus 7, the pH is going to be more than 7 and it is going to be a basic solution. Bacho. Now, I just want to say here, it's a very important. You can say H plus ion concentration related to OH minus ion concentration related to the pH calculations as well. And moving ahead, so for a weak acid, directly you take the formula from this Oswald dilution law. Here, H plus ion concentration is equal to C alpha. Okay, you can also say H plus ion concentration is going to be C alpha, so it's going to be root Ka dot C is equal to root Ka dot C. So the pH is going to be negative logarithm to the base 10 of Ka dot C to the power 1 by 2. Isn't it? Isn't it clear? Hashita, right? And you can see the pH is going to be negative logarithm to the base 10 of root Ka dot C. Ka value will be given. C is the concentration of the acid, isn't it? So C is the molar concentration, X or alpha you can say degree of ionization, Ka is going to be dissociation constant. Even for the weak base you can calculate, you know bacho, pH is equal to pH plus POH is supposed to be 14 is equal to pKW. Okay, so from this, if pH can be calculated 14 minus POH from here. So these are all the noteworthy points you can just take into the consideration. So you don't have to take the dump of the total collection of the equations and the formulas and all. These formulas should be there on the fingertips. Writing NEET examination, let it be all turbulence. One question if you do correct, plus 4. Collection of plus 4, plus 4, plus 4. How many of you dare to get 700 score? Definitely this time 600 plus score is going to be really seat getting criteria. Of course, we can do the best and we will discuss all the concepts in the strategy session here, bacho. And for the weak base, the same, you have to handle the Kb values for the weak base. In the weak acid, you have to handle the Ka values. So it is going to be POH is equal to negative log root Kb dot C. Kb is the base dissociation constant. C is the concentration of the weak base. Okay, from there you can calculate it, and once you got the POH, pH can be calculated is equal to 14 minus POH. ये दिखाई दे रहा है क्या बेटा? Yes, that would be great. Yes, very good. Students are following the class, and those students who are online, please like the session, share with your friends, subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel, and let us fight back, rewrite, raise the NEET examination, calculation of the pH of different solutions. And let us talk about the mixture of the acids and the bases here. So let's say strong acids, strong acid and strong base. So Na and Va, normality of strong acid and volume of strong acid, right? Now let us talk about NB, VB, normality of strong base and volume of strong base. When the mixture is given, if NaVa is equal to NbVb, okay, you can say the solution is going to be neutral. The expected solution pH is going to be 7. No discussion in that. If NaVa is greater than NbVb, so acid जीत गया. So that what will happen? You have to calculate Ha plus N concentration. NaVa minus NbVb upon Va plus Vb, right? Hi Sai, very good. And just give the inputs or any doubts in the chat box. So from H plus you can calculate pH is equal to negative logarithm to the base 10 of H plus ion concentration. How to calculate H plus ion concentration and negative logarithms and all? I already made a session based on how to calculate logarithms and all. And another situation here, if NbVb is greater than NaVa, so base जीत गया, so that OH you have to calculate, So the OH minus is going to be NbVb minus NaVa upon Va plus Vb. So that from OH minus ion concentration POH, you can calculate negative logarithm to the base 10 of OH minus ion concentration. And once POH is calculated, pH is equal to 14 minus POH. This is the flow you need to have. This is the flow you need to have, right? And if a collection of a strong acid and a weak acid is collected, strong acid and a weak base, and a weak acid and a strong base, you need to form the solutions in such a way that whether the product is going to be a salt, of course, if the salt and acid is left, you have to use the buffer. Only salt is left at the end, you have to use the salt hydrolysis into the consideration. So students, let us solve one more here. Yes, buffer solution. Buffer is a solution which resists the change in the pH by addition of a small quantity, small amount of acid, small amount of the base into it, or dilution, or little change in the temperature, or long storage or long standing. So these are the buffer characters. So the buffer has its own pH. So buffers are basically two types: simple buffer and a mixed buffer. Simple buffer is the buffer in aqueous solution of a salt of a weak acid and a weak base, and mixed buffer is a solution. These are two types. One is acidic buffer, another one is a basic buffer. You see the flow in the subject. The same flow you need to maintain. Definitely all the questions you can solve with a lot of chill mind. So if it is an acidic buffer, it is a mixture of a weak acid and a salt of a strong base. If it is a basic buffer, it is a mixture of a weak base and it's a salt of its strong acid. So you will be having a acidic buffer and the basic buffer. In the NEET examination, you will be asked to say which of the following is a buffer. That's a very famous question. Students, here example, you can say acetic acid, sodium acetate, phthalic acid, potassium phthalate, boric acid and borax and sodium bicarbonate, and citric acid and sodium citrate. It is a mixture and they can act as a weak acid and they can be an acidic buffer. So bacho, you can say the basic buffer is a buffer prepared by mixing of a weak base and it's a salt of a strong acid. So an example, ammonium chloride and ammonium hydroxide, and a glycerin and a glycerin hydrogen chloride. So glycine and glycine hydrochloride, and these are all okay. And also you can ampholites. Ampholite, the compounds contain both acidic and basic groups like amino acids, okay, like an amino acids. So amino acids and the proteins, you are the bio students, you might be knowing about this perfectly. They can act as a buffer solution. You will be having assertion reasoning type solution. Amino acids can act as a buffer, statement 1. And statement 2, amino acid behave like an ampholite. So statement 2 is the correct explanation of statement 1. Like that, you need to focus on NEET examination. But your NEET examination directly don't ask you solve a big numerical lengthy calculation. No, you will be asking, testing about what is your understanding level. Let somebody is given the paper, somebody is leaked the paper, it doesn't matter. Rather, NTA is so particular about it is going to NTA question papers will be in the such a way that they test you your understanding ability. So not more than that. Okay, bacho, moving ahead, a mixture of normal salt and acidic salt like NaH2HPO, sodium hydrogen phosphate and sodium phosphate has a buffering action as well. Believe it, if option is there, it is also a buffer solution. You open any books, this kind of things are available and you can do the best. Salt of a weak base and a weak acid like ammonium acetate, ammonium cyanide kind of salts, aqueous solutions can act as a buffer, but their buffer capacity बहुत कम होता है, but they are good buffers. Talking about buffer capacity, so buffer has the ability to resist the pH at certain level, that is indicated by buffer capacity. And the buffer capacity, the number of moles of acid or base is added upon the pH change, that is what is called as a buffer capacity. Buffer capacity is indicated with the pi. Okay, so let us talk about the Henderson-Hasselbalch equation. So for the acidic buffer, pH is equal to pKa plus log, this is the salt concentration, salt by acid concentration. For calculation of pOH, pKb plus log conjugate acid and weak base. So I mean to say, if the salt concentration is equal to acid concentration, the buffer capacity is going to be maximum, its maximum value is in the pKa plus or minus 1 तक इसका buffer capacity अच्छा तरफ काम चलेगा बेटा. And even for the basic buffer, the same scenario, you can say pKb value is plus or minus 1 tak chalega. Understand? Add it out, bacho. And moving ahead in the salt hydrolysis, when acid is reacted with a base, gives rise to salt and water, and delta H is going to be negative exothermic process. This is what is called neutralization. This is what is called as a neutralization. If the salt is reacted back with water, gives rise to its corresponding acid and base, delta H is going to be positive. It is essentially endothermic process. So that as temperature increases, the salt hydrolysis increases. I am connecting this ionic equilibrium with thermodynamic and Le Chatelier principle concept as well. So NEET examination, you will be expecting such a logical interpretations better. Believe it or not, bacho, those who are online, please like the session and appreciate the effort from our side by liking the session, sharing with your friends and subscribing to this channel. So I'm very much happy to help the students from this YouTube channel to take you to the ReNEET, and it is re-rise, and take this as an opportunity to score better on June 21st as compared to May 3rd examination. Can you stand on that word? Once you stand, give me a thumbs up and fire emoji in the chat box. Bacho, here I just want to talk about hydrolysis at a glance, only one. So salt, nature, degree of hydrolysis constant, the pH. You are going to have the various types of salts, salt of a strong acid and a strong base. Its pH is going to be neutral. There is no hydrolysis. pH is going to be 7. And when it comes to the weak acid and the strong base, okay, and anionic hydrolysis takes place, CH3CO minus, and anionic hydrolysis takes place, and the nature of solution is going to be basic, and the hydrolysis constant is going to be root KW upon CKa, and C is the concentration of the salt. Hydrolysis constant is going to be Kw by Ka, and the pH is going to be pKw plus pKa plus log C by 2. So directly you can use the salt hydrolysis for this particular salt, right? Any doubt? Any doubt? Okay, let us go ahead. Similarly, strong acid and weak base, example ammonium chloride. Here in this ammonium chloride, ammonium plus and Cl minus, ammonium plus, cationic hydrolysis takes place. Whenever cationic hydrolysis takes place, it is going to be acidic, and you're going to have pH is equal to pKw minus pKb minus log C by 2. If it is a salt of a weak acid and weak base, both cationic as well as anionic hydrolysis takes place. Identification of the statements, statement based questions, and match the following type questions are very important. So the solution can be little acidic or little basic, and you see degree of hydrolysis is independent on the concentration. C term is not there in the H value, right? So this is independent on the concentration. Degree of hydrolysis is independent on the concentration of the salt for a salt formed by the weak acid and a weak base. And you know, the pH of the solution is pH is going to be slightly greater than 7 if pKa is Ka value is greater than Kb value, if Ka value is greater than Kb value, and vice versa. And also you can calculate the pH by using pH is equal to pKw plus pKa minus pKb by 2. This particular slide can tell you, this particular slide can give you expect 4 marks in your NEET examination. Take a screenshot everybody. 3, 2, 1, click. And moving ahead here, solubility and solubility product. Solubility is denoted by S and it is expressed in mole per liter. So solubility is inversely proportional to the concentration of the common ions or number of common ions. That's very, very important. You are directly taken to the common ions into the action. Okay. And moving ahead, a solubility product KSP, if it is taken as AgCl, gives rise Ag plus, it is only applicable for sparingly soluble salts. KSP is going to be Ag plus concentration and Cl minus concentration. Let us say solubility of this is S. KSP is going to be S dot S. S is equal to root over KSP. Like that you can calculate. At the saturated stage only you have to use. And the application for the precipitation is very important here. If it is a calcium fluoride, calcium 2 plus and F2 minus a square. Silver chromate, Ag2CrO4, 2 Ag plus CrO4 2 minus. Okay, Ag plus a square and CrO4 2 minus you can say. Any doubt? But you're expecting you guys to give the doubts in the chat box. So come on, let's talk about AB gives rise A plus and B minus. Solubility product in the general representation, A plus to the power X and B minus to the power Y. And you know, criteria and precipitation. Solubility product and the criteria of precipitation. If KSP is equal to ionic product. So both are same, but KSP is taken at the saturated solution only. Ionic product taken at any instant before saturation and after saturation. If KSP is equal to KIP, ionic product, the solution is said to be saturated. If KSP is greater than ionic product, the solution is still unsaturated, precipitation do not takes place. And if KSP is less than ionic product, then it is going to be a supersaturated and there will be a precipitate. This is a very, very important. This particular slide can directly extract full marks, 4 marks for one question. Okay, bacho. And this is the where we completed total ionic equilibrium. And in the next session, electrochemistry also will meet it, and it takes some time. Okay, and let us discuss some more concepts. If required any other concepts, so please let us know, and I will be very happy to help you. Right. So thank you. I am done for now. Let us see with more stuff in the next upcoming sessions. Stay tuned. Those students who are online, please like the session, share with your friends and subscribe to Sri Chaitanya Academy Infinity Learn NEET YouTube channel. So I am here signing off. So let us re-rise in the re-NEET. Thank you very much. Bye-bye.